Hi, this is Kirtana from Sri Venkateshwara College of Engineering, Bangalore. Let us discuss about the topic moment area method and conjugate beam method in the subject analysis of structures with the subject code 21CV44. Introduction. The moment area method and conjugate beam method are two important techniques used in structural analysis. These methods help engineers determine the internal force and moments within a structure. Both methods rely on mathematical equations and graphical procedures to analyze and solve structural problems. Moment area method overview. The moment area method is used to determine the slope and deflection of beams subjected to various loading conditions. It involves calculating the area of moment diagram to determine the displacement or rotation at a specific point. This method is based on the principles of equilibrium and compatibility of deformation. Steps involved to find slope and deflection in the moment area method are: number 1. Draw the bending moment diagram for the given beam and loading conditions. Number 2. Calculate the areas of bending moment diagram between the desired points. Number 3. Use the areas to determine the slope or deflection at the desired point using appropriate formula. Here we can see some of the examples given. In this diagram, we have to find slope and deflection. The slope formula of any point is equals to area of BMD divided by EI. EI, which means modulus of elasticity and moment of inertia. In the other hand, deflection at any point is equals to area of BMD divided by EI into x bar which means centroid distance from the center. In this slide, we can discuss about the conjugate beam method overview. The conjugate beam method is used to analyze beams and frames by replacing the actual beam with an imaginary beam called the conjugate beam. This method simplifies the analysis by converting the BMD moments into shear forces and vice versa. The conjugate beam has the same length as the actual beam, but it is loaded with a specific set of virtual loads. Let us discuss about the steps involved in conjugate beam method. Number 1. Replace the actual beam with the conjugate beam by considering the appropriate boundary conditions. Determine the bending moment equation for the conjugate beam using the given loading condition. Number 3. Calculate the shear force and deflection equations for the actual beam using the derived bending moment equation. In this diagram, we have to find slope and deflection using conjugate beam method. Here we have to remember some of the points, that is slope in real beam is equals to shear force in conjugate beam. Deflection in real beam is equals to bending moment in conjugate beam. After this, we have to find slope and deflection using the formula. Comparison of moment area method and conjugate beam method. Both methods are used to analyze beams and frames subjected to various loading conditions. The moment area method focuses on determining slope and deflection, while the conjugate beam method analyzes internal forces and reactions. Moment area method requires calculating the area and the bending moment diagram, while the conjugate beam method involves deriving equations for shear forces and deflection. Advantages of moment area method. It provides accurate results for determining slope and deflection. It can handle complex loading conditions. It allows for graphical interpretation and visualization of bending moment diagram. Advantages of conjugate beam method. It simplifies the analyzes by converting bending moments to shear force and vice versa, enables easy determination of reactions and internal forces. It can handle both statically determinate and indeterminate structures. Limitation of moment area method. It requires a good understanding of calculus and mathematical equations. More time it consuming compared to other methods. It limited applicability for structures with changing cross-sectional properties. Limitations of conjugate beam method. It is only applicable to linearly elastic and homogeneous materials. It cannot directly provide slope and deflection values. Does not consider shear deformations. Example problems for moment area method. Here, the problem is given, that is, a simply supported beam ABCD carries a uniformly distributed load W, a concentrated load, that is I, as shown in the figure. The Young modulus beam is 200 GPa. The cross-sectional of a beam is also shown. All the dimensions are given in the figure and weight of the beam is neglected. Here we have to find. Initially, draw a free body diagram for beam and find all the reactions. Give the expression for the bending moment m as function of the distance x measured from point A for all the sections. Calculate the second moment of area about the axis passing through a centroid. Write down the deflection boundary conditions at A. Calculate the deflections of the beam as function of x where left support A. Calculate the deflections of a beam at D. Here, to solve that, given a simply supported beam subjected to a uniformly distributed load, determine the deflection at the midpoint. Draw the bending moment diagram and calculate the area using appropriate formula. Using the area to find the deflection at the midpoint using moment area method. Example problem for conjugate beam method. Here, apply the curvature diagram to the conjugate beam, finding the reactions. Here given the figure. To find the internal shear force and bending moment at point C, we need to find one reaction. Let's try to find reaction B using this formula. Given a cantilever beam with a point load at the free end, determine the reactions and internal forces. Next to that, replace the actual beam with the conjugate beam and derive the bending moment equation. Later, calculate the shear force and deflection equation for the actual beam using the derived bending moment equation. Applications in structural engineering. Both methods are commonly used in civil and structural engineering for analyzing and designing various types of structures. The moment area method is particularly useful for determining beam deflection in buildings and bridges. The conjugate beam method is often applied in analyzing continuous beams, frames, and trusses. Real-world examples for moment area methods are determining the deflection of long-span beam in a bridge under the different loading conditions, analyzing the displacement of cantilever roof beam subjected to wind loads, evaluating the deflection of a continuous beam in a multi-story building. Real-world examples for conjugate beam method: calculating the reactions and internal forces in continuous beam supporting multiple floors of building. Analyze the shear force and bending moments in trusses structure. Designing the optimal size and shape for a beam based on the desired internal forces. Conclusion for both the moment area method and conjugate beam method. The moment area method and conjugate beam method are valuable tools in structural analysis and design. Each method has its own advantages and limitations, and the applications depend on the specific problem and requirements. Both methods provide engineers with the necessary tools to ensure the safety and efficiency of various structures. Thank